with the quiz, make sure you are prepared to do angles that are either positive or negative. As soon as you understand positive angles, the negative ones are the same thing. You simply rotate the other direction. So, the mic is working here. This is angle 0. You need to memorize that if you rotate completely around the circle, the angle would be 2 pi. So the location on the circle for an angle of 0 is exactly the same as the location on the circle for an angle of 2 pi. If you go backwards, you're simply rotating like so. Negative 2 pi. Does anyone have a question about the rotational angles so far? You just follow the pattern. So then, if I rotate only this far, just say it out loud, please, what would the angle be?
180 pi.
Always radians in this class, although it is 180 degrees. So pi radians. If you were to rotate this direction, you would be rotating an angle of what? Negative pi. Okay? Question? If you rotate from here to here, pi over 2. If you keep going, so this is 1 pi over 2. Now you just count. 1 pi over 2, 2 pi over 2. Then 2 pi over 2 reduces to just pi. Count one more, 3 pi over 2. Questions? Awesome. You go, please.
Could you put a negative on the list?
If we do negative, here's what's going to happen, Sarah. You start here, and you rotate this direction. We've rotated how much, Sarah?
Negative pi over 2.
Just negative pi over 2. Questions? Perfect. If you were to rotate this way and stop here, what angle of rotation would you, yeah, sort of
Negative 3 pi over 2.
negative 3 pi over 2. Question? Awesome. Show me one or two if that makes perfect sense. You'll have no trouble remembering this for the rest of the year. If you're going to have trouble, we want to find a different way to explain it. Keep track of your tally marks for today, so mark those down. One tally mark. We'll pick pebbles at the end of the period. Okay, next thing. I have found that if you try to draw angles that are pi over 3, it tends to introduce a lot of mistakes. So I don't do that anymore. I always do angles of pi over 6 because the dividing up the circle is a lot easier. So basically, I start here and rotate like about this much, and rotate again that same amount, best I can show. I'm dividing this into 6 equal pieces. Okay, questions? Did you catch up in your notes? It's just a matter of counting. So this first angle of rotation right here, this is an angle, this much, this angle in here. That's an angle of pi divided by 6. Questions? Similar if you rotate the other direction, down here. That would be an angle of negative pi over 6. If you rotate backwards. And at this point, all you have to do is count. So if this is 1 pi over 6, just say it out loud. What's this? 2 pi over 6. But you can reduce that fraction pi over 3. If you count one more, you'd have 3 pi over 6. But 3 pi over 6 also reduces pi over 2.
Mr. Smith,
Please.
wouldn't it be pi
Oh, thank you, miswrote that. Thank you, Heidi. Nasty looking 3. Everybody good? Perfect. If you keep counting, how many 6 would be to here? 4 pi over 6. 4 pi over 6 reduces to 2 pi over 3. One more, you're at 5 pi over 6. One more, you're at 6 pi over 6. Questions? Awesome. Any trouble with that? It's just a matter of counting. Okay, a lot of people put the fourths on the same circle. I find that to lead to a lot of mistakes. Plus, I don't typically encounter problems where you're dealing with both thirds and fourths or sixths and fourths. So I draw a new circle. So, one more. Do my best to do it by hand this time. So draw a circle.
That's pretty good.
Decent for, good enough. That means this angle from here to here, fourths are easy because they just split right down the middle. So this is angle 0 again. This is pi over 4. This would be 2 pi over 4. Same thing as pi over 2. This would be 3 pi over 4. This would be 4 pi over 4. Which is the same thing as pi. Any questions on the fourth angle? Okay, so step 1 is you must be able to find any angle on the circle. Forward or backwards, but all you do is count. Questions? Awesome. Okay, so once you know that, the next thing to know is, go back over to this drawing, there are 3 numbers you need to memorize. On the unit circle, those 3 numbers represent lengths. Here they are. You don't have to know the decimal value, although it doesn't hurt anything because it kind of helps clarify. Okay, here's how I memorize it. Short, medium, long. It's easy to, the pattern's really repetitive. It's 1 divided by 2. Root 2 divided by 2. Root 3 divided by 2. But the order is easy because the first one could be thought of as being the square root of 1. Just say it out loud. What is the square root of 1? 1. So this is the same thing. Just say it out loud. Which is bigger, root 2 or root 1?
Root 2.
Root 2. Which is bigger, root 2 or root 3?
Root 3.
So short, medium, long. Okay? 1 or 2 if that makes perfect sense. 1 or 2 if that makes perfect sense. Short, medium, long. So put down another tally mark. They won't usually write the root, so you'll have to take that back off. But question, Chad?
No.
Okay, the last one is 0.866, by the way. Okay, the whole point of this for our class is the point isn't to memorize the circle. The point is to be working a calculus problem and encounter some step in the problem where you have to find, for example, the sine of, I don't know, pi over 3. And you have to be able to come up with that value without your calculator, without any sort of aid. So the idea for memorizing the circle is so you can do that quickly. So when I see sine of pi over 3, what I do is I draw a circle. And then I count to the angle pi over 3. But I always count it as a sixth. So here's 1/6, there's 2/6, That's the same thing as pi over 3. So I first locate the angle, and now I simply walk to that point from the center. From the center, I have to go over some distance, and I have to go up some distance. Just say it out loud, which is longer, the red or the blue?
Blue.
Blue. It's a very distinct pattern. So the length of that blue line is the square root of 3 over 2. It's the long. The length of the red line is 1/2. The short and the longs always alternate. So it's really easy to remember. One's short, one's long. And they're always associated with angles of like pi over 3 or pi over 6. That's it.
Wait, can you say that again?
Huh? So the short and the long always alternates. And they're always, oh, go quick, right. Oh, what I mean by that is that as you go to different spots on the circle, if you're dealing with angles of pi over 6 or pi over 3, you're going to keep seeing a short and a long, short and a long. Like we have this circle right here, Sarah. This circle, the only values that will be associated with this circle are these two here, the short and the long. This one won't be associated with this circle at all. The medium one is associated only with this circle. Does that make sense?
Yeah, that's fine.
Good. Please check.
So on the medium line, are both the lengths gonna be pi over square root of 2 over 2?
Perfect. So on this circle, at any angle, the sine will be either the short or the long, and the cosine will be the opposite. On this circle, where the angles are pi over 4, 3 pi over 4, etc., both sine and cosine will be the medium value. And all you have to do after that is find the positive and negative. So when that answers your question. Yeah. So when I'm working the problem, it says sine of pi over 3. I draw a picture. The last thing to memorize, in its alphabetical order, which comes first in the alphabet, sine or cosine? Say it. Cosine. Which comes first in the alphabet? Over or up? Over. Over. Over goes with cosine, up goes with sine. Ooh. So it's just a memory trick. Which comes first in the alphabet, sine or cosine? Cosine. Which comes first in the alphabet, over or up? Over. So the over matches up with cosine. The up matches up with sine. Brody Spencer said we should memorize it this way. I don't know that it helps me, but it helped him. Cosine is the over, sine is the up. So it helps.
So like the answer of that, the sine would be the longer.
Good, so the sine is the long. So this sine got in chat. Did we go, for the up, did we go positive or negative? Positive. So the sine value is root 3 over 2. And that means, as I was saying to Sarah, that the cosine of the angle pi over 3 would therefore be equal to the short. And is the cosine value positive or negative? Say it. Positive. That's how I use this to answer this question, how I use the unit circle to answer the question. So I don't memorize the unit circle. I just know how to use it. And now I can find the sine or cosine of any angle.
But the answer is always going to be like 1/2 is supposed to be.
Just to clarify, it's not really an answer that we're getting. It's just kind of an intermediate computation. For example, Sarah, in the process of doing some calculus problem, would you is it fair to say that you might have to figure out what 10 minus 2 is? And what is 10 minus 2? Yeah, so 8 isn't the answer. It's just part of the computation. Same thing here. As you're working a calculus problem, into some step, you've got to know the sine of pi over 3. You go, oh, that's just root 3 over 2, and you just keep going. Does that make sense?
Yeah.
Good. You know? Perfect. All that's left to do, tangent. I don't memorize the tangent values. I simply memorize that the tangent of any angle is equal to the sine of that angle divided by the cosine of that same angle. So if I want to find the tangent of pi over 3, that's going to equal the value of the sine, which is root 3 over 2, divided by the value of the cosine, which is 1/2. And somebody just say it. How do you multiply? How do you divide fractions? Divide by the reciprocal. So the tangent of pi over 3 is root 3. Question. Cool, let's practice. So, figure out this one, please. I don't know. I'll do another one together, I guess. We'll say the sine of 10, no, let's go back up here. Let's go the sine of 7 pi over 6. Actually, everybody just do that one. I'll pay you to get it right. As soon as you have it, raise your hand. Sine of pi over 6.
7 pi.
What's that? Tangent's equal to sine over cosine. Just point to it. Just point to your answer. That'll work.
Yeah, you use that. This is right, yeah. Good work.
Point to your answer. Oh, close. There we go. So still something we didn't quite click yet. Point to your answer. Okay, we'll work on this one together in a minute. You don't stop it? No, close though. Only one chance on this one. Everyone's close, but not really. There we go. That's right. So that's right. Ready? What's your answer? What's your answer? Close. 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 Last chance. Anybody else only get one chance on this? What's your answer? Anybody not get a chance? Okay, here's the mistake some people made. So I draw a circle. And I count. So there's 0. So 1/6, 2, 3, 4, 5, 6, 7. So that's the angle I want. I walk to that angle. So I'm going over the long distance. I'm going down the short. Therefore, the sine of 7 pi over 6 is the short distance, but because I went down, it's negative 1/2. Question? The cosine of 7 pi over 6 is the long distance, but because I went negative, it's the long distance root 3 over 2, which is also negative. Question? Tangent, if you're asking to find that, you would say tangent of 7 pi over 6 will equal the sine value, negative 1/2, divided by the cosine value. Negative divided by negative is positive. Result is 1 over root 3. Question? Okay, quiz on this on Monday. Pretty good? Perfect. Do another one here. Strong button, sorry. Do cosine pi over 3. I won't check individual on this one. I'll put up some options. As soon as you're ready, just kind of look ready, and then we'll have the whole class vote. So just when you're done, just kind of put your pencil down. If you need extra help, call me, I'll come help. As soon as you have the answers, put your pencil down and vote together and make checking a little bit faster. If you need help, just stop me as I'm walking. So 6 cosine 5 pi thirds. I don't ever count the thirds. I always count 6. 6 again pencil. And you just count. So this is how many 6? It's actually 6. Okay, so one of those 6 is the same thing as 5 pi over 3 over 1. It's easier than you make it. So there's 5 thirds, there are twice as many 6. Because if you had a third of something, the 6 is half as big. So if there are 5 thirds, that's the same thing as the cosine of 10 pi over 6. So this is the angle. So once we find the angle, 5 pi over 3, walk that over and down. Cosine is the over.
Again, the answer short. Negative.
Positive or negative.
I did the AP test.
Sine.
Yeah. I don't know what my grades are. At first, we need to
We have a question for inverse like the sine of this angle right there is root 3 of 0. The sine of this angle is negative root 0. Inverse is whatever. So I understand you.
really like I know. It's like
Show me your answer, quick. Show me your answer silently, don't show everybody else. Just show me 1, 2, 3, or 4. Show me quietly, just silently so no one else can see. What is your answer? If you're doing this, give yourself a tally mark. We'll pay at the end of class. Draw the circle. Add circle. Okay, cosine of 5 pi over 3 is the same thing as the cosine of 10 pi over 6. So I count. Here's 0, 1/6, 2/6, 3, 4, 5, 6, 7, 8, 9, 10. That's the angle. To get to that angle, I walk over short distance. I walk down long distance. That tells me that the cosine is the short distance, or 1/2. Because I walked in a positive direction, it's a positive number. The sine of 5 pi over 3 is the long distance, and it's negative. Question? Good? Anyone want another practice before the quiz on Monday? Doing good? Cool. That's it. So next topic. So in your notes, so quiz on this on Monday. In your notes, write down the following. Okay, so we've done this kind of problem before. The problem will say there's a region that's bounded by the curves y equal root x, the curve y equal 1 over 10x, and the line x equal 4. This would likely be a calculator-based problem, so I can pull up my calculator and graph it. It's going to look like that. If you don't want to do this on your calculator, that's okay. So we have a question, Chip. You go ahead. Can't draw the line x equal 4 on my calculator, so I just use the window 0 to 4 to capture that. Questions? Perfect. So here's what it looks like on my calculator. You've done this before. They often will say find the area of that region. There were questions like this on the recent test. So I guess the one at the beginning of, actually both tests had questions like this, find the area of that region. So. The new concept today is the following, and it's best illustrated with a little video I found. So watch this. It's not really that exciting, but it does illustrate the point. No sound. It's not that exciting. Drew the two curves, just like the calculator did. You draw the line x equal 4, and they identify the region. Okay, what's new is they're going to create a 3-dimensional object now. They do it through rotation, just like what Braden just did. Oh, please, sorry.
Is there a way to graph that x equal 4?
Not an easy way on the calculator, but so I just use the window. So like on my calculator, there is a way, but it's not worth it. Seriously, too many steps. So I drew this, of course, just with y equals, this one with y equals, and then I just say window 0 to 4. So in my head, I'm saying, okay, there's the other boundary. Good question, sort of. So back to this. Did we get to there? Okay, here's what happens when it rotates. Now, one warning. to solve these problems on the AP Calculus test, you don't have to necessarily visualize what the shape looks like in 3 dimensions. You can solve the problem quickly, easily, accurately, full credit in 2 dimensions. And I'll show you how to do that. But they're going to rotate like this. It creates that 3-dimensional shape, kind of like I don't know, whatever that shape is. Please.
How do you tell based off?
It does look like an earplug, actually. Looks very much like that. Go ahead.
How do you tell based off of like the information you have which axis you're rotating about?
Outstanding question. Every problem will specify the axis of rotation.
Okay.
And so in this case, I didn't write it down, but the axis of rotation is the x-axis. So the axis of rotation is the x-axis in this case. They'll change it though, Chance. For example, here, created that shape. If they had rotated about, let's say, back to my picture on the calculator, if they rotate about a line down here, one thing that will change is the end of the object won't be solid like the tip. There'll be a big hole in the middle. Because when it rotates, it will create a big gap right in the center. Question? And you don't have to see it in 3 dimensions to solve the problem, but it kind of helps.
Is the gap because
The gap occurs because if the axis of rotation, I changed the window just a little bit, Sarah. So window, so let's go a little bit lower on the y-axis. So y min will go like -4 or something. +4 graph. So the region doesn't change. The region is exactly the same. But if the axis of rotation, we'll draw a line for it in just a second. So y equal, let's get rid of, just be a little patient. Then we get rid of this 0 one. And a different color, purple will work. We'll say the axis is -2. So again, region is the same. But the axis of rotation is going to be down here. So here's how I visualize it. Picture the region, this space in here, and picture as though there's like little thin wires connected to this line. So you can't really see the wires, but they hold this, and then you take that region, you spin it. And as you spin it, it creates a you can see the 3-dimensional shape up here. So right in the middle of that 3-dimensional shape would be this big hole. Does that kind of help?
Yeah, so then if it, when it's the x-axis, since they both start at 0, there's like a 2 holes.
Perfect, perfect. Because right here at the tip, they're both touching the axis of rotation. Right at the tip, there won't be a hole. Now if I move down into the middle of the object, because this surface is not touching the axis of rotation, the hole will still be there. It's really good, Sarah. Like here you can see it. Further along, there's a hole. There just isn't a hole down here at the tip. Perfect. In fact, this other software that I found on the internet helps illustrate this idea. And then close the window thing. Do that next time. Actually, oh, it's never mind. It's this one. So if I draw a shape that is always touching the axis, for example, like this, let's go here, 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 and then kind of curve back up like this. So that's if this is the region, and it rotates because, like Sarah said, because this was touching the axis, when you rotate, it's totally solid. Can you see it? Does that answer your question, Sarah?
Yeah.
Anybody else? Okay. Again, it's actually kind of fun. You don't have to be able to visualize it to solve the problems. What they're going to ask you to do is to find the volume of this object. Okay? Now look at me. Look at me. Don't try to find the volume by somehow equating it to finding the volume of a sphere or something. Where you're like, I don't know, like people try to like say, well, I can find the surface area. No, the approach is much simpler. Best illustrated by this thing. I should have done it on a three-dimensional printer, but I did not have the ability to do that at this point. So I did it in my garage with a special saw that cuts circles really, really nicely. So this is meant to represent what you see here. This one. It's not a perfect representation, but it's pretty close. You see what I mean?
Yeah.
Okay. The way you find the volume, it's really, really simple. Instead of trying to find the volume of the shape all at once, you just find the volume of one slice. It's really equivalent to when we found the area. We didn't find the area all at once, we found the area of a thin rectangle. We find the area of a thin slice. The slices are animated here. Watch. So just pull a slice out of the middle. The area of the slice is simple because it's a circle. So to find the area of the slice, picture it as being solid, like there's nothing missing. Just say it out loud. What's the area of the circle? Pi r squared. And then all you do is multiply by its thickness. Like some small thickness, so pi r squared times the thickness. Well, if it's a circle with a hole in the middle, you simply find the volume of two circles. Watch the pen. Find the volume of this circle as though there is no hole. So the radius of that big circle, yeah, the big circle radius starts in the center. See the pen? It's no good for the video, but whatever. Okay, starts in the center and goes all the way to here. So we're going to call that the outside radius because it goes to the outer circle. The piece we want to subtract off, center of the circle is the radius, goes to here. That's the inside radius. Question? Okay, please, Len.
So to find the entire area of the shape, could you just like integrate the original lines that we had and then multiply that by pi r squared to get the whole volume?
You got the right idea. We just have to kind of break it into a little bit smaller pieces, but the idea is correct. And so let's just keep illustrating that. You're right on track. So back to here, draw a picture. So on your paper, I don't ever try to draw the three-dimensional because it's not helpful, but the two-dimensional is essential. So draw a little quick graph on your paper. So the curve looks like this, kind of. And you have the other line coming up like this. That top one curved over too much. More like that. And then the vertical line like so. So that's the region. And then the axis of rotation. There's our region. Axis of rotation is the x-axis. So if you remember the slice, look over here again. I'll just finish the drawing first. I'm going to wait for your pencil. Okay, if you remember the slice, just say it out loud. Right, just look at me, I guess. The x-axis goes right through the center of the slice. The axis of rotation for all of these problems, it doesn't matter what the shape looks like, because the shape is created by rotating something about an axis, wherever that axis is going to be the center of every slice. Therefore, if I'm drawing a radius, the radius always begins at the axis of rotation. Does that make sense? So on your paper, draw, oh please, Chance.
Oh, I have mine.
So on your paper, draw a line that starts at the axis of rotation, always. Goes upward towards the region, and then as soon as you hit the region, stop. That length, we're going to call that the inside radius, because that's equivalent to looking at a slice, starting at the axis of rotation and going until we hit the region. If we're down here at the tip, we're not going to go very far before we hit the boundary. If we're on the other end of the object, which is much further from the axis of rotation, like this isn't a perfect representation of this, but this general idea, that radius is going to be bigger. Question? Then you draw the outside radius, same way. Start at the axis of rotation, draw a line towards the region, go through the region, stop when you hit the outside edge of the region. Or as a student said once, stop when the region ain't no more. So now that's stuck in my head for many years. Stop when there ain't no more region. Please.
So on those ones, like how the circles, the inside radius and the outside radius is kind of like the same, like the same.
Oh, gotcha, yeah.
Is that gonna be like on that one? Because that one kind of looks like two different.
No, that's very good, Sarah. Yeah, the model doesn't match this perfectly at all. It's very good. This one, like the rings are going to be kind of thin down here, and then they get thicker and thicker and thicker and thicker.
Okay,
It's
so
very
it
good.
doesn't stay the same.
Mhm. Not in that one. With the other tool, I can kind of draw what I made with the red model. So that one would have looked kind of like this, if I can figure it out. It's almost like you've got, there's a gap, first of all, because I wasn't able to, my saw won't go all the way. So the first one's got a big hole in the middle. So I create that by making sure I've got some distance from the axis.
Yeah.
And then I create a curve, something like this maybe. And notice how now the rings are going to be all the same thickness, because it's this area here that's causing the thickness of the ring. Can you see it?
Yeah.
And now I close off the shape. And it wasn't the best, but that makes sense? Yeah, same thing, right? Perfect, Sarah. Questions? Doing super well. Please.
So like, when we do this with math, the slice will be like infinitesimal, like infinitesimally small, right?
Yeah, the width,
Yeah,
the
the width,
thickness,
yeah.
perfect. Yeah, the whole idea, it's integration again.
Yeah.
The whole idea is to make each slice as thin as possible, ideally infinitely thin.
Yeah.
And then you don't have this little stepping thing going on. Yeah, with a piece of cardboard, you can't do that, but you know. So I don't have the patience. It'd actually be really cool to do it with a 3D printer. You can make the steps really, really small and you can kind of just see the real shape. So, other questions? Awesome. Back to your notes here. Okay, the next step is really, really familiar to all of you. You've used it before when you were finding the area of regions. We want to write an equation because Sarah's already noticed this. If I slice here, Sarah, is like, I'll draw it in red so they match. So way down here, the inside radius would be this red line length. Then it's this length. Over here, the red line is this length. So are those inside radius values the same or are they different? They're different. Therefore, I'm going to have an inside radius formula, not just a number. So I write on my paper the inside radius. You should write this down. Okay, the formula is really, really familiar to all of you. It's just the y coordinate at the top, subtract the y coordinate at the bottom. what, the first thing, I guess, is the y coordinate at the top always the same or always different?
Same. Well, it's the same.
Oh, bad question. No, that was a bad question. Realistically, they're different y coordinates, but they're created by the same formula. That was a bad question. So what's the formula, Landon?
1/10x.
Nice. And I'm kind of tired of writing 1/10. I'm going to write 0.1. Is that okay? Is everybody good there? What's the bottom y coordinate for every outside, or sorry, every inside radius? 0. So the inside radius formula is simply, I'll go back and forth here, is simply 1/10 x. You know the x coordinate, you know the value of the inside radius at that x coordinate. So with the model, you could literally find the inside radius anywhere by just plugging in an x. You know, which x are you interested in? Please. Right.
This one includes an interval and just do it from 0 to 4.
Perfect, perfect. Just like 2 steps away, it's perfect. So you get here, so you're right on track. We need a formula for the outside radius. So let's see. Same thing, y coordinate at the top, subtract y coordinate at the bottom. Hello. That's not my computer. No, it's Emily. Okay.
Come on, let's go.
I'm gonna plug it into the, never mind. Here, Emily's ringtone over that speaker. Moving on. What forms the y coordinate at the top of every outside radius? Square root of x. Okay, now, just a note for future problems. Sometimes what the top or bottom y coordinate will be a constant value. You know, here the bottom is just 0, but it doesn't have to be. If the axis of rotation were, say, -2, the bottom y coordinate would be -2. But this never changes. It's always y at the top, subtract y at the bottom. So root x, what's the bottom y coordinate? 0. So r sub 0 is just root x.
So you would do that minus 1/10x?
Oh, thank you.
Because it goes all the way
Give yourself 2 tally marks for that question, Sarah. That is one of the most common errors. So thanks, Sarah, for pointing it out. Don't ever do it.
Thanks, Sarah.
Okay. Sarah, on the volumes of rotation, the distance between the 2 rings isn't a radius. Like you can see it better here. This distance, that's not a radius. So if we're looking for a radius, we're never subtracting these 2. Does that make sense? Okay. Other questions? That it's always from axis of rotation to the region. And that's what gets subtracted. So now we can say this. The area, this is where Heidi was headed. The area for any circle, like the inner circle, you're looking at this picture here. The area of the inner circle is just the inside radius multiplied by pi radius squared. So just write that down. Pi inside radius squared. The area of the outside circle is just pi outside radius squared. So Landon was on track for this one. I'll have him answer it. So the goal is to find the area of what you see, the red, like just the red area that you're looking at. So how is it, Ray?
Area of outside minus area of inside.
That's it. You just think of the circle as being not missing anything, find all of the area, and then take away the part you don't want. So that means that the area of one slice, so we'll say that's the area of a slice, and we'll just call it A, better call it A area of slice. Don't want to get dangerous there. Everybody knows the joke, we'll pass on that. So, ha ha ha. Okay, so this is equal to pi r squared, the outside, subtract pi r squared of the inside. Which means for this problem, that's pi. Outside radius is that thing. Inside radius is this thing. Oops, I lost the x. Hold on. Let's step out of the way so you can catch up. Sorry. Question? Okay, so what's the purpose of the x in that formula? It says area of a slice is equal to pi root x squared minus pi 1 over 10 x squared. What's the purpose of the x?
Is that for whatever slice you're doing?
Perfect, it's whatever slice you're working with. So I simply have, every slice has its own x coordinate. I choose which x coordinate I'd like to know the volume of the slice of, or the area of the slice of. Then I do what Chad said. You multiply by a thin amount. What symbol is going to represent the thin amount? D of x. It's a small change in x. So we do what Heidi said now. We say the volume of the object. So we integrate from x equal 0 to x equal 4. This. That will give you the volume of that object that was right here. Question? Please, Sydney.
Could you integrate them first and then plug them into the R squared?
Let me get it one more time. I'm not sure
So
which
could you integrate like the square root of x minus 1/10 of x, and then once you get that answer, can you plug that into the higher square?
No. Yeah, you literally have to, the computation that has to occur, I may be wrong here, I wasn't quite sure understood what you said, so we'll say it back to you. But the computation that has to occur is I've got to find a way of finding the volume of what you see me holding. And to find that volume, I have to know this area in red, multiplied by the dx amount. So I can't really integrate something else.
No, like you still integrate the, never mind, I'll just.
You're okay, no, keep saying it, it's good, you're good. Say it one more time.
Okay, so instead of, okay, so you have pi, and then of square root of x squared minus pi 1 of 10 x squared. You take the pi
Oh,
and
yes.
x squared out, and then just do the asterisk.
Can't take out the x.
I mean, no, not the x, the pi, okay, so.
You can take out the pi.
Yeah, so do the equation, do pi r squared after you integrate, like, the square root of x is 1 over 10 x by themselves.
Write it down on paper what you're thinking.
No, this is.
You're not sure. You can factor out the pi. In fact, here's the formula I want you to memorize. Is because the pi is in both terms, it's a multiplying factor. So you can pull out the pi. The formula I'd like you to memorize is this. You start the integral where the first slice is located, the x coordinate of the first slice, like Haley said. You end the integral at the x coordinate of the last slice. All that you have to have inside the integral is the formula for the outside radius squared. Subtract the inside radius squared. That's it. Wow. Caution, hey, don't ever say outside radius minus inside radius all squared. That's not mathematically equivalent. That's not the right answer. It's wrong. So it's the outside radius squared. Just think of where it came from. We had to find the area of the outer circle, subtract the area of the inner circle. Chance.
I don't know. I have something stuck in my head and I feel like it should work, but I don't think it does. And I can't get it out of my head. So if you look at the graph, you have your shape. Why can't you just find the area of that shape first and then multiply that by 2 pi?
It would be pi r squared.
Like, you want to find the surface area of the shape? Like, what area of the shape do you want to find?
I want to find the surface area and then multiply it by 2 pi.
Like 2 pi?
Yeah.
Sounds really easy, it doesn't work.
I mean, why doesn't it work though? I feel like it should, because there's
So
find
give me
the surface area, and then the circle is in full radius, like if you go fully around is 2 pi, so it shouldn't.
There is a way, let me say it back to you. There is a way, they do this in BC, we won't do it here, using what are called polar coordinates to find the volume in a rotational manner that way.
Okay.
We won't do it here, but there's ways, so. They've had these problems in both sections of the test, but remember this, hey, the setup basically has to be done without the calculator anyway, other than the picture. So if it's in a section of the test where you can't use your calculator, they will usually give you something to kind of help you reference it, or at least enough. And then from there, finding the value of the integral isn't necessarily difficult, just depends on what you're integrating. Because now you just find the antiderivative and plug in. Okay, good. We're going to stop there for a minute. I'm going to pay you till the bell rings. So.